So our next panel is chaired by Jason Zarowski from ESnet. So I'm just going to hand it over to him to introduce the speakers and take it from there.
So much, Vass. And we're going to have two speakers that are here in person, and I will let them introduce themselves. And
Mike Benedetto, American Museum of Natural.
And then we also have Jim returning for his sophomore year, doing yet another panel because he was very willing to help us. Jim, I don't know if you can hear us or if you're out there. If you want to introduce yourself.
Can you hear me?
Yep, we can.
Great.
All right. Well, that's who we are. Now, what we're going to talk about. I just wanted to give a little bit of a reminder for people who may not know what a Science DMZ is before we get into probably spending most of the time with the panelists instead of me just talking about this technology. I always like to throw this picture in because I think it represents a lot of the ways that people try to start with data mobility solutions, where someone comes to a conference much like this and they hear about this great thing, Globus, and they hear about, oh, I can just go and find myself a server and I'll plunk it down wherever. And then I'll turn it on and hope that it just works. And that is often when we get calls and people go, hey, how come you recommended this thing? It's really awful. It doesn't work. It's not pushing data out effectively. I'm not able to share with people. What gives? And when it comes down to it, there's a lot of technical reasons why this is going to be a problem, whether it be trying to have things pushing data out through campus infrastructure that is being shared with all kinds of other enterprise use cases, or whether it's being pulled back through enterprise firewalls that may be stepping on TCP flows. Whatever the case is, we do try to encourage people to adopt a little bit more of a standard procedure for doing this. And I was talking with a CIO a couple of weeks ago, and he said, you've been using the same picture for 15 years. What's new with this? Why do I need to adopt this? Because it just looks like something that's 15 years old. Clearly it can't work. Well, and you know what? My retort was, it hasn't changed because it's effective. And this sort of mentality of trying to move out your big data pushing appliance to the edge of your campus, still trying to respect the per service security policy using controls that are not instituted by a big firewall, and thinking carefully about what the use case happens to be for your different users really is the most effective solution. And everybody has implemented this in different ways, and we're going to look at 3 examples here from Penn State and American Museum of Natural History and TAC. But the basic idea here is that if you do not have mechanisms in place that can handle bulk data movement or streaming data as we move into new different use cases, you're going to be subjected to the performance hits that you often see when you do the previous example of just sticking it somewhere in campus and not thinking carefully about the engineering that goes into this. So this is what we're trying to do here. We want performance to be a first-class citizen within the campus design. And we want to make sure that the IT departments of your various institutions, sites, facilities, whatever you happen to be representing, know what the requirements and expectations are going to be looking like. And this is going to then trickle down to the researchers because they need to understand what they are going to be expecting from IT and infrastructure performance, really just trying to build these bridges so that everybody is communicating with a level setting mentality of trying to get this stuff done. So with that, I think that I'd like the panelists to sort of speak to their specific environments first. And then we have a couple of canned questions that we sort of thought up ourselves, but we want to really turn this over to the audience as best as we possibly can, because we know that a lot of people have questions and want to bring things up. So I think the first picture that we have up here is the American Museum of Natural History. So Mike, if you want to talk to this diagram and let people know sort of the basic idea that on your campus environment with. And here's a pointer if you'd like it.
Okay, so I have to look at it occasionally because I'm getting older. So even though I drew it, I forget what it looks like. But one of the first things that people always say when I come to something like this is a museum. They think of us as like a big dead zoo, not a lot of data, things like that going on. So it's always the first question, what's a nice museum like you doing in a place like this? And what most people don't realize, the American Museum of Natural History and all of our exhibits and our education programs and everything is backed by data. We have two data scientists. We have 200 scientists spanning multiple disciplines in biology and astronomy, astrophysics, earth and planetary sciences, anthropology, biodiversity conservation, as well as exhibit conservation and object conservation. scientists at of 200 scientists. Keep going out, I think. We also have students. We're a degree granting institution for PhDs and Masters of Applied Teaching of Science. So we have a lot of that traditional education type work going on. So a couple of years ago, we brought in a Science DMZ to help with that data transfer because we were collaborating all around the world, all around the country, collaborating with NASA, various universities, places in Europe. So we needed a way to get the data in and out fast. We found that the putting it into, the FedEx packet and shipping it via FedEx wasn't always the most effective things. We had a couple of use cases that we came up with, one in particular with one of our researchers doing work at Mount Palomar Observatory. Rather than collecting up the data for a week, bringing it back and seeing if she had a hit on the data she was doing with telescope time, was more about, can we get the data back every night, take a look at it that night and see if she's looking in the right spot, part of the sky. That was just one use case, and we found literally dozens of others. So the way we structured our Science DMZ, we're in New York State, so we're connected to NISERNet as our research and education connector, brought a Juniper MX240 in, and then within the same data center, we have a larger QFX 10K from Juniper that's serving up all the content. We broke our Science DMZ into a couple of zones. So the gray zones that you see up here are our external facing devices. This is where our DTNs are. This is where our HPC that are our Science DMZ and Internet 2 facing are. And then there's that red strip there, and that is what we called our Science High-Speed Access Network, or SHSA. I didn't come up with a really great acronym that sounded cool for that, so that's what we have right now. The idea there was some of our researchers had high-performance workstations that they were doing a lot of data back and forth with. So essentially, we created that and then created a routing cut through directly to the DTN. So if they needed to get something from a workstation in their lab directly to the DTN, they could cut through very quickly across the Juniper, but they were also wanting to do email and other things on those boxes. So all of the remaining data not going to our DTNs would go through the traditional network. And then the blue areas on this is that traditional enterprise network where all that data is flowing. Those enterprise networks are behind the firewall. Everything else on the Science DMZ is really at the endpoint. And that's where we're doing the security there. So what it actually comes into, does it work that way? This is what it looks like in practice. So you can see we have a number of clusters that are directly connected. Each one of our clusters now has its own Globus endpoint associated with it. So if you need to move things in and out to that particular cluster, it's got its own mounted Globus endpoint there, as well as a number of other specialty nodes. We have a few that are DTNs with some compute on it. And then some of our researchers are using Globus Personal on their workstations, either in the offices or at home now, because the pandemic forced a lot of people home, and Globus Personal helped them move that data back and forth to our computational clusters, as well as from source data at another university. They were able to bring it directly into the cluster, do their work on it, and have the processing there. So that's kind of how it's structured at the museum.
Have the TAC diagram.
Yeah, so I had never met Mike till this morning. So I'm listening to him talk, and I realized we built the exact same thing and never talked about it. And we kind of wear the same hats in life as well. So, you know, we both are CISOs, we both are network professionals, both security people, construction people as well. But as you see, so I didn't do the full on blown out like he did, but it's the same concept, right? So, you know, we're a little lucky here. We are a research facility, right? So we're at UT main, we're at UT camp, we're at UT Austin proper. But, you know, we can build whatever we want, right? So we are the quintessential Science DMZ from scratch. And it's been this way for 20 years now. You know, it wasn't called Science DMZ before, but it's the same thing. The only difference is we peer directly with campus, right? So all of our offices, all of our other stuff are not part of campus. It's peered, and then it kind of runs through thing. But, you know, anything that needs, like, cut through path is one way to put it. We actually don't use cut through paths at all. We avoid the firewall at all. We simply go to the things that need the fastest thing. So for that, it's our DTNs, Globus, our login nodes for large systems, and kind of everything else, the service nodes. Anything that needs a lot of speed, we kind of shunt around the firewall. But, you know, one thing, you know, talking to Mike today, because again, it was weird, like meeting a twin almost. You know, we are doing things that are important, right? So one thing I realized today at lunch is it's poorly named. Science DMZ, immediately you're in battle. You're implying that we need to go to war. This is not a wartime footing, right? This is something that is good and helpful, right? This helps the community, right? So, you know, as I was sitting here thinking today, we need to refocus this name and call it something else. Two, the thing that came up today is we no longer look at these things about devices and things with workflows, right? So Jason and I working on a project for Arecibo. So Arecibo fell down. They called Jason. He's like, hey, they got 3 petabytes of data. They don't know how to move it. And I was like, cool, where's that? They're like, well, it's still under the telescope. We can get to it. And I was like, okay, what's that involve? He's like, well, we can get some NASs, load them up, put them in a car, drive them across the island of Puerto Rico, and then we can do the Globus transfer there, and that should get it. And I was like, cool, done the math, it'll take us a year. He's like, yeah, probably, but that's what it's gonna take, right? But, you know, so that's one workflow, right? But, you know, when we start thinking about how we help the scientific community, when you start thinking about workflows, and kind of what is best for the user to get them to us, to get their research done, right? Because if we say no, by default, we'll never come back, right? So we wanna make sure that we're enabling them to their science. And sometimes I'll show you this, but I build custom things as well when researchers need it, right? So, you know, I realize we have built the same thing, so that's pretty cool. I guess we're not wrong. But, you know, this model is been around for a long time and will change coming forward. You know, we see things more like, you know, users are dying for things like Kubernetes and OpenStack, right? Those things are happening, right? You're going to be initializing your network faster than you think, right? So, you know, this model will change coming forward, but as it stands, if you just replicate this in a virtual environment, it works too. So that's mine.
Thank you. And now the Penn State diagrams. Jim, if you want to talk to this,
Okay.
I can advance when you're ready.
Sure. This is what, Ken Miller, who's going to join us later on this panel, he was my, what I call a partner in crime for a lot of this. And we originally got a grant money, it's from the 2012 CCNIE, as it was called then, now the CC Star program. But for about a $500,000 grant, we developed this concept of a research network, which was our version of the Science DMZ. We realized not only did we have firewalls, we had firewalls at every department, we had central firewalls, we have data center firewalls, and there were many cases where a researcher's data, when even going to and from the high performance clusters, which we at the time called ACI, the Advanced Computation Institute, to and from would go through firewalls like twice on the way across campus. So we designed this network not only to be friction free from the outside, which is a more traditional Science DMZ, but I think like the case of the museum is that we needed researchers to have high-speed access to their data and to computational resources on their local workstations in some cases. And so what you see here is what we call the crab diagram, which separates the border, the core, the academic part of the university, and the research part of the university. And the lines that represent our DMZ was where things go through the border router via ACLs rather than going through a firewall, and that's much faster and more friction free. And so we designed it this way. And the original design was for about 15 buildings on campus, where we noticed over the years that their interaction with data coming from the internet in general, or more particularly going across campus to the high performance clusters, was the largest. So that's how we identified our targets in the first place. But we actually, part of the mission of the CCNIE grant was to say, okay, now use the lessons you've learned developing this and push it across your institution. And that's exactly what we did. We used a lot of the lessons learned to improve the next generation of what we call our UEN, the University Enterprise Network. So Penn State is not just the University Park campus where I'm housed, but we also have a medical center in Hershey, Pennsylvania, medical college there too. And then we have 23 Commonwealth campuses, and we actually have 2 law schools across the Commonwealth of Pennsylvania. So we have a big problem of data movement regardless. If you live in Pennsylvania, you generally live within about 30 miles of a Penn State campus or location. Next slide, please. So this is just a more general thing. This represents really what I was talking about, the problems that we had before with what we call horizontal flows across campus. And this is where we were getting in that situation, and it's the orange line, and you'll forgive me that I am colorblind, but it's the orange line in this diagram where we were going through firewalls back and forth across campus through the core. Instead, the research network, we improved that by getting rid of that friction, and those are the blue lines, and then those are also sort of the greenish lines that are coming from Internet 2 onto campus, particularly onto our high performance computing environment. But one of the things is that Penn State has had a long tradition in atmospheric science and meteorology, and so we serve as sort of a data hub for the eastern United States, particularly the Northeast and central states. So we get data from NCAR, National Center for Atmospheric Research, National Weather Center, National Hurricane Center, and we repackage that into smaller products, and we distribute that to maybe 25 to 30 institutions across the eastern United States. So that's the typical example that I use when our CISO or our information security, they say, well, we need to keep this data safe. And it's like, it's yesterday's weather. Who cares, right? You know, except for people that are researching it and perhaps producing forecasts as a result. But the big thing is when we're in the middle of a hurricane or developing tropical storm, we want to be able to get the data as fast as we can so we can predict, you know, weather, hurricane paths, storm paths, and actually move assets in and out of danger zones. So next slide, please. And this is so this is a view of what our typical, most workstations have 1 gigabit ports on them, and this is typically what they see and but they can get very quick access through the university core network, the University Enterprise Network, to our Science DMZ, and they can load data down there and then load it directly into our computational clusters, and then they use their traditional slower networks to do the data visualization and connect to things like Open on Demand to do their computation. So that's sort of the 3 diagrams that I have, and some of the explanations that I have for why we got to here and sort of what it looks like now. What it looks like now is very typical what somebody with a 1 gigabit connection sees.
All right, thank you, Jim. So as I said, we have a couple of QA questions that we queued up for ourselves because, hey, we can do that. But it's more exciting if people ask them. So I'll just sort of look over to Vas. Do we have any that are active right now? If there's not, I can kick us off with one of the canned ones. Okay. Well, then I will ask the first one here, and I'll just randomly assign who gets to address it first, I suppose. So the first question that we thought about was, how are users onboarded to use your facility Science DMZ and data movement hardware? So let's start with the museum first.
I'm also loud, so I don't know if this is on or not. So, okay, it is. Now that I'm echoing, great. Loud guy from New York, who would have guessed? So whenever anybody is brought into the museum, they're automatically assigned an account, kind of in a disabled state. Our scientists will be, have them then turned on when they need access to either one of our DTNs or our HPC. We essentially are flagging them in our LDAP system. And then in most cases, in a cron job that goes out, it'll, activate them and grant them all the rights. Sometimes it's done across the board, across all of our scientific research capabilities. Sometimes it's done on specific systems. Really depends on what that researcher needs, but we try to standardize in that way. We have a slightly different approach for some of our V4 Globus systems. There's still a few there, but we're moving to V5. And as it moves to V5, it's more of that automated system. On the V4s, we have to kick off some kind of a process to do it. But essentially, if you're in our research departments, you're kind of granted that general access, and then we turn you on to specific tools as they're needed for you.
Okay. Let's do Jim next.
So early on, the way we did it is we have something which is called RCCI, a group which Research Computing and Cyber Infrastructure, which really is a faculty-run governance organization over the research IT of the university. And we designed a process, and again, when I say we, I usually mean Ken Miller, who you hired away, Jason. Thank you very much. So usually I say, so Ken Miller and I designed a process where we had a faculty interview early on, and we had some agreements in terms of data use, because originally the security office was very concerned about that this was going to be the wild west of networks. How can you run a network without a firewall? And so we had to have some things that I would say maybe artificially constrain what they could keep on their workstation, but actually sort of grease the skids a little bit for onboarding them. After that, after we got a lot of the initial customers in place, we set up a process through ServiceNow where people open a ticket and it goes into a network request. And still, for most of them, we do a data interview. We want to know what their needs are. Quite frankly, some people reach out and they, I need 100 gigabit connection to this workstation or whatever. And we sort of very subtly talk them out of that. Well, maybe you don't, or and in some cases it's been a systems problem that's masqueraded as a network problem. The RAIDs aren't set up correctly, or there's no way that a disk throughput could keep up with the kind of networks that we have. So generally, if they open, all they have to do is send a note to research network at psu.edu, and it opens a ServiceNow ticket, and it goes into where we can see it, and we assign people to go out and do a data interview with the faculty member or the research group in question. So that's generally our onboarding process now, although it started with a big campaign of awareness when we first rolled out the research network.
Right. And having been a part of some of those interviews during the early days,
Absolutely.
Calling them interviews was a little bit charitable. Some of them got a little heated. But hey, we're here today, and it's functional.
We made it.
All right, Tech.
So we're Tech, so we're Texas. We are the first Cowboys, but we do things. We think it's such a vital resource that all users get it by default, right? So the way you get an account attack is you have to. So from the PI perspective, is you have to submit to either XRAS or LRAC or some sort of allocation system. So you're granted hours in those systems. So you then get an allocation on the machine. So either Stampede, Frontera, Lone Star 6, whatever we got, right? And then that is automatically on by default, right? So we have a DTN hanging off every single compute node, every single machine. And then we think it's so valuable that you guys should just have access to it. So you guys can go on, grab it, do whatever you want. We're the inverse problem. So users are usually pretty self-serving, self-sufficient. They can usually pull data where they want. Usually our biggest users are coming from other institutions of scale. So we see flows that are ginormous sometimes. But when we get the special cases of people having problems, we then step in to help. But we find that like 80% of the folks can use the documentation and get going fine by themselves. Some people have some interesting workflows that need some help with, and we get to some custom things. But there's really only a couple ways to send things in securely anymore. SCP is still a big gun, even though we think it's silly, but it works like amazingly. Globus, and then we see some Aspera too. But other than that, there's not really many secure things that come across the wire. So by default, everybody gets it because it's awesome. And I think that's how the world should work. So we keep it that way.
So I'll pause there and see if we have any other questions before I go to my second canned one.
Just a reminder for those online to post your questions in the Q&A. We don't have anything right now. Is there any questions in the room?
Okay, they're all a Twitter because they want to hear the answer to the second question. So I will just ask it. How do you handle data transfers with special security considerations? So I'll go to Jim first on this one.
That was some of our initial cases. So we have an enclave system, a data enclave system, and we have levels of data classification at the university. 4 levels of data classification at the university. Most of the research traffic is what we call 1 and 2, which is fairly low stakes research data. We do have a secure enclave or an authority to operate on our largest cluster at the university. And so they are authorized to handle everything but the most, they can't handle classified data, but beyond that, they can do that. So most of the traffic, it's not a problem. And where we have to set up specific flows, we can do that on the network.
Okay, Tech.
So this is kind of I think this is where everybody's going, right? So clearly 171 is going to be the future for everybody, right? That's kind of what's being seen around the world. I mean, not around the world, the US. So, you know, TAC carries a full stack. So we carry 53 stack and we do 171 stack as well. So we're fully compliant. So we do HIPAA, ITAR, EAR, you name it. And, you know, we only have 2 data classifications. That was not smart to figure it out. So either you're in the bucket or you're not in the bucket, right? And so if you get in the bucket, you have the highest form, which is for HIPAA. We follow the FISMA model, but, you know, once you get in the bucket, you're fine. But, you know, so we don't let anything across the wire that's not encrypted, right? That's one of your basic 53 controls, right? Or 171 controls. So for us, everything has to be encrypted. So we use the Globus encryption pieces, which is fine, looks great. And that's how we kind of do it. You know, our economies of scale are kind of huge. So we have about 20,000 nodes and we can support a full stack this way. And so it doesn't matter how it comes in, as long as we follow some generic rules we want to follow based on the NIST standards, we're pretty good. And, you know, a thing like Globus actually helps us out with this tremendously, right? Because one, we have, you know, we know who's doing it. 2, we know it's encrypted, and 3, we know it's secure.
Museum.
A little bit easier because stuff is, you know, we do this from various animals who have not asserted their rights not to have a DNA sequence, or we're not dealing with PHI or health data at this particular point. So we're not doing those kinds of human trials. So it's been okay at this, you know, point. We are ready to be able to take that stuff on. We need to be able to bring that on as a possibility. We also may want to look at some of our partners because we try to partner with institutions. Maybe somebody is set up more to handle that data than we would be at the current time. So if it's more efficient for us to partner with somebody to say, let's do this analysis here because their whole system is structured with that, that is something that we would explore with the researchers. So simply put, I mean, part of what we're trying to be is facilitators for the researchers and open up this data to them, kind of democratize this data. So part of my role as a CISO, who is usually the least popular guy in the room right after the network guy, who I also am. So I'm just fun at parties. And the idea here is that when you're the CISO, so many people have a direct view of us as just the people that say no all the time. And that's kind of an issue we have to get over. On the inverse, we really need to be more reasonable and work with everybody to say, how do we get you from where you are to where you need to be and maintain that security? So partly it's about us being service enablers, which is what we should be. And partly about it is trying to teach the researchers and the other people in the IT stack how to ask for something from the CISO in a way that does not immediately have us slap them down. So one of the things they were saying with TAC is, you know, Science DMZ is I'm sorry, guys, it's a bad putting it. And so this really should be something that we're doing that's open more. We're not on a wartime footing. If you say DMZ to CISO, he's immediately thinking, or she's immediately thinking, there's a firewall and it's either hanging directly off the firewall or it's sandwiched between 2 firewalls. So you've already got them thinking of somebody and you say, okay, now I have a DMZ, which you understand, but it has no firewalls. You might as well ask that CISO with the color blue. they're not going to answer it. They're not going to want to answer it. You've already set them up and broken the methodology that they have there. So it's a little bit of a different conversation. And so some of what we need to do is really change the way the conversation is held on both sides. It's not a either or. So yeah, mostly I'm going to take all my really secure stuff, put it in his bucket attack and beg for an allocation. That may be easier. He doesn't know I'm already doing it.
Good. But you know, he makes an excellent point here is, you know, this is such a force for good and we treat it like it's an enemy, right? And that shouldn't be the case, right? We've had, you know, I was asked earlier, this year alone, which I did 1 calendar year last year, we pulled in 33 petabytes via Globus, 42, and we did another 80 internal transfer, right? So that's a lot of data flowing in, right? It can only work because we have things like this, right? So that's thousands and thousands of researchers who did their job and got the science done because we had allowed these things, right? So to me, this has to happen for science to work, right? And I tell this before, you know, no users, no jobs, no funding, you don't have a job, right? As simple as that sounds sometimes, right? We have to be able to enable users to do their science and just get out of their way a little bit, right? I'm also a scientist, right? I have to change my stance. It's always a yes now. And then I have to figure out what that really means, right? So, you know, this is a really important thing, right? We have to change the way our methodology works here in order to get science done, right? Otherwise, these big toys are useless, right?
No longer putting the no in innovation then.
Right.
Okay, as long as we're all on the record with that.
I mean, yes, with the asterisk.
Let's see, you know, like, is that gonna work? Maybe. Yeah.
So we have one question online, which is, why is it called a science DMZ?
Eli Dart couldn't be here today. Eli, for those of you that do know him from ESnet and LBL, himself, and if I remember all the people who were involved in the room that day, Brent Draney, formerly of NERSC, who I think is at Meta now, just like everybody else I know. And I want to also say Paul Henderson, formerly of PPPL, who I think is blissfully retiring and fishing with his grandchildren. It was all a part of a conversation that they had where there was this notion of a traditional DMZ that many people may be aware of just in network design. And the idea came down of, why are we treating science data any differently than this? So that's where the origin story comes from. It was approximately 2010. So, you know, we're approaching, you know, so almost 15 years of having this as being an entity for good within the community. And, you know, certainly I concur that rebranding may be in order. It may just be the sort of thing that we need to push out to people as being a force for good versus the wartime footing, as you both said so eloquently. So, you know, it'll be my job to go and convince Eli. I'll have to take that on.
Well, Eli's been saying this for longer. And so,
yeah.
And I will actually say that we were pitching our CC Star grants to our senior vice president, who, you know, heads up all of our institutional advancement. First thing she said is, I hate the idea of having something. I didn't tell her that for 20 years before that we had other DMCs, but she didn't know that. But it was the view of a DMC as a military thing, not as a research thing. And this is a person who is not a research computational person. So she just had an emotional reaction to just the name, and I get it. So we just didn't use that name and moved on, because it was just, this was the accepted parlance. I don't know really where it comes from, but it doesn't go there.
we avoid it. We just call it the network. I mean, seriously.
Okay. Any other questions right now?
We don't, but I will jump in. Actually, let me get Carl first here.
So I apologize. I've been over diagrammed by the initial slide. So if the answer to my question was there, I completely missed it. We've had a situation for a long time where researchers would go out to third-party companies, private companies, for work, typically sequencing work, and then they'd get the results back. And by far, the results would be coming back via, and I apologize, I have to use the word, via SCP, or even occasionally via HTTP. And researchers at Stanford, so this is Carl from Stanford, researchers at Stanford operate completely on their own schedules. And when they were on campus, would quite happily transfer to their laptop and then to cluster storage because they got symmetric gigabit. They're at home now, and they might get close to gigabit down, but they're getting single or 2-digit megabit up, and they then hit that problem. So there's been pushback of offering some solution for that, because if you give a person a login to a computer, they will use as much as they can. So I'm kind of curious what you guys do for that situation where somebody is executing a command locally to go out and pull data into their environment.
You go first.
I mean, I think some of it's a training issue. And the first question we have to ask is, but the idea here is that does the source of data you have already have Globus? And then is the destination for that data one of our clusters? And then we can easily point out this data transfer node, this share is right on the cluster. Let's bypass your laptop altogether, because if you're pulling down all that data, it's also messing up either your kid's Xbox Fortnite game or your ability to watch Netflix or your Zoom call. So now the idea is, can we kick off that transfer between the 2 points? And that works. We've also found, and this is something that I speak to several passions. Again, people would say, why isn't UCM at some of these conferences? Why are you there? And the idea is they didn't realize we had so many scientists and didn't realize that we were actually using a lot of their researchers. And the first time I ever went down with TAC, they were like, oh, you use TAC resources? Yeah. Some of our researchers had allocations. This is great. So the idea here is there's a lot of data at small and mid-sized places, relatively speaking. And the question is, can we, some of them have not heard of the Science DMZ, some of them have not heard of the DTN or Globus. And so I kind of try to champion this a little bit by saying, it's not hard to set up. You may already have an Internet 2 connection. You're halfway there. Now can I move this up higher for the people in the cheap seats? And I'm sorry, I tend to be loud, so I don't even realize if I'm not on mic. But the idea here is, can we pull or help other institutions get a DTN up? So, okay, so.
While I swap myself. Oh. Yeah. So, we're lucky at Tech, right? So we have, most of our users are old school. We're still command line, a lot of SCP, a lot of SSH, right? But we do have a lot of users recently who are doing other things, right? Who are not savvy in Linux, who need some Windows help, right? So, you can teach them how to curl, you can teach them how to SCP and all those things, right? But a lot of people will need to click. We run things like VNC and, X11 forwarding, but it's a high bar for a lot of some of our less sophisticated researchers. And, we literally had to stand up Windows boxes for them and then put a bunch of GPOs in so they could do their research and pull things down, right? RDP this box, go for it, do it, right? And, that's a small percentage of our users, but they're doing stuff that is important. So we need to make sure they have that ability, right? Now, when you put, exposed Windows services to the internet, no one gets happy about it, right? Your cyber insurance liability in particular gives you a call. I'm sure we'll have that conversation at some point later. But, so we do things like multi-factor across our Windows environment as well. So, but the pandemic taught us a lot of good things, right? And, all the bad stuff we don't want to talk about, but some good things happen, right? Is how do we get people working from wherever they are, however they can, right? Because we weren't sent home because it was like, oh, vacation. We were sent home with no tools, right? Just like, good luck, hope we'll see you soon, right? So, but we've gotten better as the past couple of years have gone. It's like, how do we make sure the tools work for users wherever they are? And, that is really what's changed kind of the way people are starting to work now, right? I don't care where my staff sits anymore. I don't care, right? But now we have gotten better about getting these tools out there so people can do whatever they need, wherever they are.
And one thing I was going to say before, and I think it was probably, my gigantic chubby side that was blocking it and handing there. But the issue that I would say is a lot of you guys a lot of people on this call, a lot of people in this room are at big universities, are at big facilities. But you may have researchers collaborating with people at the museum, at the Smithsonian, at a community college. If you do not think that the data that these smaller institutions have because they're not an R1 is not important data, then you're really wrong. There's a lot of it out there. So I'm kind of going to lay a challenge at a lot of people's feet. you know, we've said, hey, we're using Globus, and they'll say, well, what's Globus? And it's like, can you help these smaller institutions that might not have DTN? And DTNs are not expensive. Globus is relatively not expensive. You can help them, and it becomes a way of getting all this data locked away into the community, into your researchers' hands, into collaborators' hands. And that's just helping science across the board. And once you have that access, and once you're playing with that data back and forth, and once you're contributing, you also find out that people want to work more with this. They want to collaborate more. And this is really what it is. Science is collaborative. So the challenge that I would lay at a lot of the larger institutions is it's worth your time to help smaller places who may not be on this pathway open up, because it'll help everybody, the community and yourselves and your researchers included. And so that's kind of my soapbox moment, but it is something that's really important.
And before Jim, we give Jim a chance to answer, what you said just triggered something, a synapse in my mind. We recently did a review of use cases at a community college, and CIO, you know, said, yeah, you're not going to really learn anything great about us. We're small, we're about education. But, you know, we had a researcher there, a teacher and researcher, who in his off time, not even something that he's funded to do, takes students down to Honduras on diving trips and is taking drone pictures of coral reefs. And we're talking, you know, basically high order terabits that he needs to figure out a way to deal with. So we're going to be contacting you pretty soon.
Yep.
But the end of the story there is that, you know, unless you ask, you don't know. So it's one of these things that even if you are a small institution, you probably have these use cases, and you have to initiate these sort of conversations.
Those researchers in those community colleges are your researchers tomorrow. Those students are your future researchers.
Yeah, I mean,
So-
for every LIGO, there's 1,000 other researchers who have small collections, right? You know, well, we talk LIGO and all the important stuff and all the weather stuff, but there's thousands of them who have small collections who only need, you know, our average ask is 5T. That's it. We think that's a rounding error, right? But that is important to them.
Jim, anything else you wanted to throw in?
Yeah, I mean, I think that's a really good point. And when the Stanford person that asked the question, he brought up SCP and HTTP. We deliver a lot of data back and forth to the Commonwealth of Pennsylvania, and we're talking FTP there. We're talking anonymous FTP there. So we you know, and we also have the ag research centers, you know, we ag extension offices throughout the 67 counties of Pennsylvania, and Penn State runs those. And a lot of times they, you know, they have pretty slow cable modems, and it speaks to what you're talking about the asymmetry of the connection, you know, ADSL or cable modems. And one of the things that we learned during the pandemic was we had set up virtual labs, which we call web labs, which is basically an RDP into Windows machines that are actually on in the labs that they're in, and you're on it even though you're not on campus. And it turns out these are very good waypoints for moving data. If you want to move data onto campus or onto campus, around campus, these are good places because they have both very symmetric, you know, ingress and egress networks, and they're on the Penn State network, and you have access through two-factor authentication to them. So those turned out to be a real blessing in disguise, not only for the teaching mission of the university, but it also helped out a great deal with the research mission of the university.
All right. Other questions from the audience, Vass, before I ask another canned one?
Do you have experience with any connectors to Globus Connect server, like cloud providers or internal Hadoop to tape libraries? Do you use any of those?
In terms of connectors, so we've been going through this massive migration out of box and into other things, and as a result, we've been using the S3 connector. We've been using the box connector and the Office 365 connector in terms of that. And and I would say the limitations of those are the limitations that are put on by the vendors at the endpoints. And one of the great features of using Globus connectors, particularly to Office 365, is the reliability and the ability to pick up those connections when they get dropped and just not have to restart at the beginning, but just continue on moving the data. A lot of the data migration tools that we use, if they fail and you start all over. They have no idea where they are. So the real benefit of Globus connectors are just the ability to pick up and retry and guarantee that the integrity from end to end point. That's been huge for us. I don't know that I can speak directly to tape robots or Hadoop or anything, but those are the cloud platforms in addition to our traditional cluster and DTNs that we use the connectors for.
Do you have anything else that you wanted to add for yours?
No, just tried out a couple of them so far.
Yeah, I mean, so we have access to all of them, right? So we played with, Azure, Google, and AWS. Everything works. It's fine. It's great. It's the right tool for the right job. It's how we view these things, right? Hadoop specifically, we don't see a ton of people run Hadoop anymore in the science world. They do other thingies now. So not Hadoop per se, but Globus works. The connectors work. We don't really think too many thoughts about it, right? Usually it's just kind of plug and play.
Do you see Spark?
No.
Okay.
Before you jump to the next question, I just want to go back to the point that Mike made on his soapbox and tie it back to the previous discussion around talking with CIOs, CISOs, whatever you, especially at the smaller schools. How do you have that conversation? Because we get pulled into that when that researcher says, what's a Globus? And they come to our website, it usually lands on some of my team's email. And then we have the conversation and we say, oh, by the way, the first thing you should do is set up a Science DMZ. And then they go, okay, what's that? And then we tell them, and then they go to the CIO, whoever, and they say, DMZ? No, right?
Yeah. So number one thing that we did a couple of years ago, more than 5 years ago at this point, was we started having active conversations with the researchers. And one thing that you'll see on both of our CC Star grants is while the CIO is the PI on both of them, and I'm a co-PI on them from the technical side, each one of them has a researcher in the PI as a PI, one of whom is now our provost. So it's great. We have support for what we're doing at a very high level on both the science and the IT side. And I think that that's important. I see too many people say, okay, we're going to go for a Science DMZ grant. We're going to go for a compute grant. And they call the IT, if it's researcher facing, they call the IT people like 2 months before the thing is due and say, I need prices, I need a map, and I need a data management plan, and go do it. By the way, you can't have a firewall, CISO's head explodes, it's over. The idea here, and this is probably, in my opinion, the best thing that came out of the CC Star program, and it's not technical and it's not research, it's a conversation. So if you're on the technical side or on the research side, we have to start having the conversation before the grant solicitation even comes out. Start figuring out what they do. I was having conversations for years with our researchers. I had a pretty good sense of what their science drivers would be. Don't ask me to explain them. They've tried to teach me them. I'm not a physics, I'm not a chemistry guy. So that's not what I can do, but I knew that they had data needs and stuff for several years before we put in our first submission. That conversation allowed us to have a level of trust between us. Now, I'm also the CISO for the museum, so I argued with myself a lot because ultimately, if I did this wrong and we had a breach, I was going to be held responsible. And if I did too much and it didn't work, I was going to be held responsible. But I think the idea here is that if you are trying to give your CISO a crash course on a Science DMZ or an open network, you're destined to fail. If you talk to them before it, warm them up to it over time, it helps. And the second thing is that if we approach this as I want to come to you to make sure that what I'm doing is secure from the outset, rather than jam it in on you, and then you have to figure out how to secure it, which is usually by saying no, then it's a different conversation. The other thing is if we we have to start talking about the endpoint as the new perimeter. the firewall is great. You can bypass it. All your other controls, your IPS, you can bypass all of this. Phishing proves that. So now if we talk about the fact that we're securing the endpoint and then working our way back there and just making it more secure, now you have a very happy CISO as opposed to an adversarial CISO, but it starts with a conversation. That, in my opinion, is one of the biggest legacies of the CC Star program, which so many of us have used to get here.
Let's lunch a little bit. And so one thing we need to do in our world is stop changing our perspective of if it gets compromised to when it gets compromised, right? So we know they're going to get us, right? So just what's your plan, right? What's your mean time to failure? Why do you come back, right? You know, because it's going to happen, right? So how are you prepared for that, right? So, you know, we can do everything to harden we want, but we got to make sure that we're on top of things. And then if it does get popped, what do we do, right? You know, is it just a simple user excursion? Fine, right? Are they gaining root through something? You know, I don't know how many guys fought Log4j or are still fighting Log4j, right? You know, that thing is popping up in places you didn't know existed, didn't know it was a thing. You know, literally there's one maintainer in the world for that version and he didn't do a great job of maintaining it. And then they redid it and it's, you know, still more garbagey, right? So, but you know, this is the thing, right? We can harden all the endpoints, but you know, critical to your future happiness is you have to also lay the groundwork for, we're gonna get popped, right? So what do we do when we get popped? So that's also another thing we need to start thinking about as well.
Jim, anything else you want to throw in? I want to have the last word, so I'll give
No, go.
Jim the chance here first.
No, go ahead. Grab the last word.
Okay, I'll grab the last word. So, you know, excellent question, Vas, because, you know, Vas knows that the other hat that I wear is with the other part of my job, which is the EPIC Center, jointly funded with Indiana. And that's actually our whole job, is we ask these sorts of questions. So if you're sitting out there going, I'd like to talk to my researchers, but I don't know how to start that, you can actually just come to me and say, hey, do you want to talk to my researchers for me? And I'm funded to do that. I'll talk to as many as you want. I love that stuff. In fact, you know, the ongoing joke in my group is that I'm actually not technical anymore and they don't let me touch the network because, you know, all I do is talk about like, you know, gut bacteria and frog biology, right? It's because that's the stuff that is exciting to me. I want to know those workflows because once you talk to the scientist about that workflow and they say it has this part and this part and this part, you then get to go to the technology people and go, all right, this is what they're saying. Can you do any of this stuff? Well, yeah, we do that today. How come they didn't come and ask? Because nobody ever links those things together. So if that does resonate with anybody, if you need help in understanding what your scientific community is doing within your campus, that is a conversation that we are always happy to have. Just come and talk to me after this. So I think that we may be getting close to time. I don't know if there's time for one more before Ken's presentation. I'll look to the moderator here. 10 minutes, so okay, well, why don't we try to do one more before we go to Ken's? Is there any active ones out there right now, or should I ask one of the last Ken questions? None? Okay. All right, which one of these do you guys want to do if it's our last question? Did you have a specific preference on which one there?
The data performance?
Is that the one?
I think so.
Number 5? Okay, yeah. All right, well, let's do the second half of 5 then. How do you validate the performance of your network and your storage? What form of measurement and monitoring do you perform? TAC.
Well, I mean, so, you know, step one is, you know, all of our DTNs directly attached to storage, right? So, you know, there's multiple networks going these things. So FinMed connected directly because we want to have the fastest possible path to storage. That's it. You know, Jason still makes use ProSonar. I hate it, but there's no better tool for these things. You know, it is a good quantifier measurable of are you getting things across your network correctly? We know we're not spindle bound. So, you know, we don't ever look at that because, you know, we have thousands of drives behind these things doing all the things. And then, you know, straight up old school networking, right? So just, you know, we use Zabbix and we use flow monitors and, you know, your tool of choice, right? But, you know, 9 times out of 10, the problem is not us. It's us figuring out where the user has a problem. Usually it's MTU related trying to get to us, right? So there's a lot of those things, but, you know, your basic stuff works, right? So, you know, if I'm wearing my CISO, having to preach hygiene. So, you know, always patch and my network hat, always do the simple things, right? Those things still work. They're super effective and they will give you insights in your data that you didn't know were there.
Yeah. So I love the fact that so much of what he does at TAC, we do at the museum. So if this proves anything, it's that this whole system scales up, it scales down. You don't have to be huge to make it work. You don't have to be small. So I love the fact that it just scales. That's cool because we're direct attached storage on most of our DTNs, everything like that. We're making heavy use of perf sonar. I would like to report that, when I saw a lot of places put a Science DMZ in because perf sonar was required in the grant. They put it in the Science DMZ, they put it nowhere else. I have one on my enterprise network in my traditional DMZ. I have one in my Science DMZ. I have one on my internal network. And the biggest problem it helped us solve was a couple of weeks ago. It was a Zoom problem. And it turns out that on my map, I actually have an IPS, a 10 gig IPS between the enterprise network connection and my Science DMZ. And it's a transparent bump in the wire. And it started having a nick that was going on the fritz. And the way it manifested itself was, very stuttery Zoom calls. And I love to blame the internet. I tried for a little while until one of our guys said, hey, I just looked at the perf sonar between our internal and our Science DMZ box, and it's performing really badly. And then I had to blame my own network, which was a terrible thing to have to do. But the point of this is too, again, if you're trying to like warm people up to the idea of doing this, we were required to put one perf sonar node in the Science DMZ. We put multiples in and had them start talking to each other. And lo and behold, it actually spotted a problem. And we were able to fix it that afternoon, which was great. So I'm glad that one of my engineers said, hey, did anybody look at perf sonar? And great, it worked. So we kind of do those things, and it's an inexpensive kind of a thing. So this is the other area. All these solutions are out there and they're fairly inexpensive for us to be able to do, which is helpful to the smaller institutions who think that this is coming from R1 and these are the places. This has got to be expensive. It's not. My bandwidth costs were the most expensive part of my entire project.
Quick side note, it's actually super easy to install as well. So it really is a low barrier to entry.
It's a good thing we wrote that software in 2004 then. Jim, anything else you want to
Yeah,
add?
no, Persona, invaluable tool. We've used it to troubleshoot a major WAN routing issue all the way down to a bad fiber at Goddard Space Flight Center that was hindering a transfer of climate data. So, again, my partner in crime, Ken Miller, is the real expert on that. And so we have instrumented a lot of our network, not just, and I agree with what Mike said, not just the Science DMZ, but a lot of our network and our campuses, and particularly our medical campus, with some perf sonar nodes so that we can detect problems as they're happening.
All right. So with that, since we said perf sonar and Ken Miller, I think it's time to throw it over to Ken Miller for sort of the close down thoughts that we had for this panel. And he wanted to talk a little bit about the data mobility exhibition. So I will get out of my slides. If Ken's slides are up here, I can cue them. Yeah, actually, I can't because I don't know how this works because I don't know how computers work.
Okay, I can just share mine if you want.
It is.
Ken, if you could just share directly. Yeah, should be able to switch over to that from the Zoom session.
Yeah, I did. So
There we go.
got it. All right. Just kind of a follow on to the using perf sonar and data performance and data transfer performance and tying back to network performance. These kind of go hand in hand. A lot of what we're seeing is a lot of Science DMZs were implemented with perf sonar, but people forgot to really test their data architectures and data transfers after that. So what we've done, we've built a kind of a data transfer performance framework similar to what perf sonar does for the network that allows you to test your data transfers to and from your data architectures or DTNs or even remote collaborators. And we do all this through Globus. So this kind of ties into that. We've integrated this with what Epic was doing, what Jason mentioned earlier about being able to talk to researchers and different systems like that, whether understanding the workflow, whether it's understanding systems or storage analysis or anything related to those collaborations. So we've kind of integrated that directly there, but like I said, this is just one of the focus areas of Epic at this point. So. So we have these little kind of charts to see where people are at. And sometimes this is like, oh, where do I fit in here? So we're kind of highlighting, as putting some baselines out there for people to look at. So on a 10 gigabit DTN, so nothing too extravagant. Typically, they can run anywhere between $2,000 and $4,000, depending on the amount of local storage you have on there. So they're not very expensive to start off with. We're trying to set a minimum transfer baseline of 2.2 gigabits per second on this as a minimum standard. We know we can do some tuning, get those up to 6 to 7, sometimes even 8. But again, it's just what's going on is we're finding out through this discovery process that a lot of sites aren't even getting this 2.2 gigabits per second, even though they've got, multiple $100,000 for a Science DMZ and put a brand new network in 100 gig, yada, yada, yada. But people forget to test their data transfers. So they've had perf sonar set up, they built a mad dash, they've done all these things, but they forget to do the data transfers. So this is actually using Globus to stress test your network, your systems for MTU tuning, as well as your storage subsystem, whether it's local in the DTN or whether it's direct attached storage to some other kind of a storage system. So as we get into this kind of ties back into some of the expectations here. Like I said, we have a breakdown here in a little bit I'll go through, but really our 1 terabyte per hour is what we're trying to set our minimum baseline at for the researcher's view. What that relates to in the networking world is 2.2 gigabits per second, or to a sysadmin or storage, it's 277 megabytes per second. So as we're getting into these systems, that's about where we're at. Sometimes we had someone ask about, what about a 1 gig campus connection? What should we see through that? And typically a desktop nowadays should be able to handle a 1 gig connection pretty well. So you should be able to transfer 1 terabyte in around 3 hours, or 800 bits per second, or 100 megabytes per second. So that's kind of the rough numbers we're looking at that. So if you don't know what these numbers are, or your researchers don't know, how do you know what to expect, whether it's a good transfer or not? So this kind of is where we're stepping into this fabric here, or this testing fabric. So the way the data mobility exhibition works is we have a handful of well-tuned DTNs, or DTN clusters that are on the outside of your perimeter, your campus network, that you can test to and from. You can upload and download your data sets. So if you're making a change, you have another system, you're putting some new equipment in, you want to, whatever these things can be, you can do some baseline testing here to see where they're at. You can upload and download the data sets, as I said, and then measure them against a 1 terabyte per hour transfer, or whatever your rate of choice might be. And then you can actually see what you can do to improve that. So far, the last 2.5 years has been almost 11,000 tests completed through this program so far. So what we did was we put 2 lines in the sand. This program is really generated from what the petascale program that happened a few years ago, which is where a number of the supercomputing centers across the country got together and said, well, we need to raise all boats, if you will. So that's really where the petascale came in. And what that rate was, the ability to transfer 1 petabyte per week. So I'll have a chart here in a minute that kind of breaks that down a little easier. But so we kind of put 2 lines on the graph, and you can see the large scale numbers there that are crossing the yellow line. That actually is what the petascale numbers are from the well-tuned DTNs as part of this program. But the rest of the blue lines on there, the averages of across the various data sets related to the 1 terabyte per hour baseline. So that's kind of where these numbers come into play. So this was transfers from unique sources by the universities. And then if we flip that and do the downloads there, you kind of see we have some other sites that are performing pretty well through that. And then we have some other sites that are still below the red line. So this is what we're trying to do, is understand, with all the money the NSF has spent across the building cyber infrastructure and the Science DMZs and CC Star program, how well are people transferring the data? Even though they put perf sonar on there and things like that, are they really going back and transferring their data and try to see what kind of speeds they're getting? So this is kind of the baseline metric we're looking at, and these are just a general view of the tests that have been completed so far. A few of the regional partners that have been working through this, we just kind of call those out depending on, especially if they're Epic partners. So the way this is set up, currently the testing sites are up at Cornell. There's one at NCAR. There's another one at Argonne. Actually, 2 at Argonne now. I called out in the bold there. ESnet has just put one online in Washington, D.C., and we have another one to be installed in Chicago at Starlight shortly. The server's already there, but we're just working out some technical, issues. In addition, there's also 2 cloud connectors associated with this program. So if you want to do some testing out to the cloud drives, they're also included in this. There's some limitations to that, but like I said, you can do some baseline testing to verify and validate your network or your data architecture. This is the data transfer scorecard, or the DTN scorecard as we call it. What we did was we really it was difficult depending on which audience or which group of people you're talking to when you're understanding this. So you have the researcher themselves as you start the engagement process. You might, include a network engineer, a network admin, or someone, your network manager. Then you also might have a systems administrator or a storage administrator, but they all 3 speak different languages when it comes to data transfer rates. So we kind of compiled that into a kind of a lookup table here to kind of see where you're at. And we highlighted the minimum baseline here as 1/6 of a petascale, or 1 terabyte per hour. But we also included in the network and data transfer rate for the researcher, or for the network engineer and network admin themselves, as a 2.2 gigabits per second. And then for a storage or system admin is 277 megabytes per second. And you can kind of see whether you're not above or below this line. In the previous graphs, it was red. For some reason, I made this yellow to confuse everyone. But that's kind of what we're looking at. And then you can see as you do some tuning and increasing, you can kind of step up through this, through these numbers to get to there. If you have a larger than 10 gigabit data transfer node, you can kind of relate yourself to how well you're transferring against the petascale numbers. So 1 petabyte per week is there only around 6 terabytes per hour, or 13 gigs a second. So this is kind of the scorecard you can take away from this to try to validate and see where your transfers are going, again, using Globus to do this. One analogy we use is, for example, if you're driving down the road and your car was going less than 20 miles an hour, you're probably going to pull off the road, get a tow truck, get a tune-up or something like that. But what about your DTNs? If they're performing under 2 gigs, you really want to contact and try to do some testing and tuning on this to improve it. And again, Epic's here to help if you need be. Again, this is just a thing. If you think about what you do in your personal life as you're driving or whatever, if you're going to have some of these issues, you probably want to get some things fixed. But people neglect their DTNs, and really that's what this program is about, is creating a performance framework around testing that. So Epic's here, available to do any testing like this. Any other pieces you want to do to, whether you work with your researcher, validate your workflows, test your network, making sure you're preferring research and education networks first over commodity. A lot of these things can come into play, so you can contact Epic here as part of these, as part of this process. And again, the data mobility exhibition was really just one of the 6 areas within that. So individual links I kind of added in here. If you want to look at those, there's really what NetSage, which is a flow measurement. I think Nathaniel mentioned that earlier, is paying attention to your flow going across your network. These are different links. You can look up your own university and kind of look at some of your transfers that are going through some of the regionals. And again, if any other questions, here's the links to the program, the testing, and then some of the automated tools that Vas has shared. Otherwise, there's the Epic contact and my own contact. So any questions?
Thank you, Ken.
Yep.
I know we're a little over, but first let's thank our speakers. And I will just piggyback on the DME stuff and say that if anyone has an interest in participating in the DME, we have a few endpoints, as Ken mentioned, but a couple of them are defunct. So we're looking for folks who are willing to just set aside a paltry, maybe 8 terabytes or so of space to replicate the data set. I'm sure you'll have tons of storage lying around, right? So hopefully you can join this. It's a community effort, and hopefully you'll be able to help us out.